Hello to all, welcome to the channel Money's Gate Tech Vision. In this lecture, I am going to solve gate problems to find the transfer function using block diagram reduction methods. So already in the previous lecture, I have explained the block diagram reduction rules. You can view that lecture series also. Here I am going to solve some problems to find the transfer function for a given system. Let me move on to the problems. This is the problem number 1. So one block diagram is given. We need to find the transfer function C of S by R of S. Transfer function is nothing but the Laplace transform of output to the Laplace transform of input. So in this block diagram, we are having the output signal flow as C of S and input signal flow as R of S. So we need to find the ratio of C of S by R of S. Okay, here G1, G2, G3 are the system elements. Normally system elements will be represented by its gains. So G1, G2, G3 are the gains for the system elements. H1 and H2 are the feedback element representation. So why it is a feedback element? So here, see here, from this output signal flow, the output is taken out and it is given to the input through this summer. And here from this output, the output is taken out and it is given to the input through this summer. So we can term it as feedback element. Okay, H1, H2 are the feedback gains. So now we need to find the transfer function for this given block diagram. The given block diagram should be reduced to a single block which represents transfer function. Now we can reduce using the block diagram reduction rules. Now I am going to use the rule. I am going to move the takeoff point after this block. Then only we can eliminate the feedback loops. Okay. So here I am going to move the takeoff point after the block G3. Moving takeoff point after the block G3. So what is the rule? Moving takeoff point after the block means we should include the reciprocal of gain. Reciprocal of gain means that corresponding block is G3. So 1 by G3 should be added. So I am drawing this G1, again on the summer, G2, G3, and the upper loop is same only. Yet we didn't reduce that. Upper loop is same only. And in the lower loop, I have moved the takeoff point after the block. So I am including the reciprocal of gain, which is 1 by G3 in this signal flow. Okay. Now see here, observe this. This is one negative feedback loop. R of S and C of S is the input and output. So here, this is a one feedback loop. So I have named this as feedback loop 1. And here, see here, this is a cascade connection of blocks. Cascading gains. That means for the cascade connection of blocks, gains should be multiplied. So by eliminating the feedback loop 1 and cascading the blocks. So how we can eliminate the feedback loop? G of S by 1 plus G of S H of S. So in place of G of S, we are having the system element gain as G2, G3. Product of G2, G3. Okay. So it will be reduced to G1. After elimination of this feedback loop 1, this gain will become G2, G3 by 1 plus G2, G3 into that feedback element gain is H2. Okay, I have eliminated this first feedback loop and I am cascading this connection, cascading these blocks. That means the product of H1 and 1 by G3, that will become H1 by G3 input output. Again see this is also a negative feedback loop. Okay, so I have named this as feedback loop 2. I am going to eliminate this one. So here G1 gain and this gain are in cascade connection, so we can multiply these gains and after that we can eliminate this full loop. So eliminating the feedback loop 2, this will become, the numerator will become G1, G2, G3 by 1 plus G2, G3 H2 by 1 plus this whole gain into that feedback element gain is H1 by G3. So here in the denominator term, I am going to cancel this G3. And then after that we can reduce. Taking LCM here, we can simplify this transfer function to C of S by R of S equals, and this denominator term that will get cancelled. C of S by R of S equals G1, G2, G3 numerator term by 1 plus G2, G3 H2 plus this term is G1, G2 H1. So what is the answer? See here options are A, B, C and D. Here we are having C of S by R of S as G1 G2 G3 by 1 plus G2 G3 H2 plus G1 G2 H1. So option A will be the correct one. Option A will be the correct one for this problem. Okay, the transfer function. Let me move on to the next problem. So here also one block diagram is given and two summers are given in this block diagram, two gains and two system elements which represent gains and two summers are given, and here both are positive operators, and from the input the takeoff point is taken out and it is given to the summer, and here also from the input it is taken out and it is given to the summer. Okay, first let me redraw the block diagram first, and then we will find the transfer function. So I am rewriting the block diagram here. 1 by S summer. So I have considered this as one loop. Again 1 by S. This is another loop. Okay, C of S is the output and R of S is the input. Now see here, from the input R of S, the takeoff point is taken out and it is given to the summer. So both are having positive operators. So we can consider this loop as parallel loop. Okay, for the parallel loop conditions, gain should be added. So here gain is 1 by S, and in this place we can represent it as unity gain. So unity gain means that unity gain and 1 by S must be added to reduce the block diagram. So this will become 1 plus 1 by S. So after eliminating this parallel loop, it will become 1 plus 1 by S. And then 1 by S is the gain. Again another summer. Now this 1 plus 1 by S and 1 by S are in cascade connection. So we can cascade this. That means multiplying its gains. Cascading the blocks, multiplying its gains with 1 plus 1 by S into 1 by S. Summer. Now again from the input, the branch point is taken out and it is given to the summer. Okay, so we can consider this as parallel loop 2. So for eliminating the parallel loop 2, we can add the gains. So this gain and unity gain must be added. So 1 by S plus 1 by S square plus 1. So which is simplified as 1 by S plus 1 by S square plus 1. Taking LCM, S square plus S plus 1 by S square. That is the transfer function for the given block diagram. And next one is problem 3. So here observe this block diagram. Here we are having two input, R of S and D of S, only one output. So this type of control system is called as MISO system. That means multi-input single output system. Multi-input. What are the inputs here? R of S is one input and D of S is another input. And C of S is only the output. Multi-input single output system. In this we are having two or more transfer functions. Okay, and now I will read out the question. In the system shown in the figure, to eliminate the effect of disturbance D of S on C of S, the transfer function GD of S should be. So they asked this transfer function. Okay, they asked this gain GD of S. Mainly this gain. They asked this gain. So we need to find full transfer function. Then we have to take out this GD of S. Okay. So first I am cascading these two gains. I am cascading these two terms, S plus 5 by S plus 10, 10 by S into S plus 5. So by cascading, we can multiply the gains. By multiplying the gains, this S plus 5 and this S plus 5 get cancelled. So the final, after that, the block diagram is reduced like this. Okay, D of S is another input signal. And here, we need to apply the superposition theorem. What is the superposition theorem? Only one input should be active to find the response. Okay. So if we want to find the transfer function, the other input should be deactivated. That means other input should be eliminated. That effect should be eliminated. So what are the possible transfer functions? C of S by R of S and C of S by D of S. So here C of S by R of S. When we want to find C of S by R of S, we need to eliminate the effect of D of S. That means we should substitute D of S equal to 0. If we want to find the other transfer function C of S by D of S, we should eliminate the effect of R of S. That means we should substitute R of S equal to 0. Okay. So now we need to find GD of S. So we need to find GD of S means we have to find the signal flow first. So for this signal flow, what is the signal flow here? Only C of S is taken out. So C of S is the signal flow for this summer. And here, what is the output signal flow here? We can represent the output signal flow here. Output, what is output signal flow? Input signal into gain. So here input signal is D of S. D of S into GD of S is the output signal flow here. So that signal flow, it is given to the summer. Okay, this R of S and C of S and this GD of S, D of S, that is given to the summer, and that output is given to this gain, again this summer. Okay, so we can reduce that. Output signal flow, here also output signal flow. Now we will write the equation R of S minus C of S minus D of S, GD of S into that gain plus D of S, plus D of S plus D of S equal to C of S. Okay. Now eliminating R of S because we need to find this GD of S means D of S should be there. Okay. So I am going to eliminate R of S equal to 0. Then only we can find the GD of S. So here in this equation I am going to substitute R of S equal to 0. Okay. By substituting R of S equal to 0, this term will become D of S into 1 minus GD of S into 10 by S into S plus 10. And by taking C of S term to the right hand side, this will become C of S into 1 plus 10 by S into S plus 10. So now we can find the transfer function C of S by D of S. Okay. So numerator term S square plus 10S minus GD of S by S square plus 10S. By denominator term S square plus 10S plus 10 by S square plus 10S. Now here numerator, here both the denominator will get cancelled. Both the denominator will get cancelled. And then it will be reduced to C of S by C of S by D of S equal to S square plus 10S minus GD of S 10 by S square plus 10S plus 10. Now we need to find the transfer function GD of S from this. So I am going to eliminate the effect of D of S, but because that is a condition given in the question. So to eliminate the effect of D of S means we need to eliminate the transfer function. The transfer function can be substituted to 0 to find the GD of S. Now I am going to substitute this transfer function to 0. So if we substitute any transfer function to 0 means that denominator term will get cancelled. Denominator term will get cancelled and only numerator term will be there, S square plus 10S minus GD of S 10. From this we can find GD of S. GD of S is simplified as S square plus 10S by 10, which is S into S plus 10 by 10. Option B is the correct one. Okay. So far we have solved some gate problems to find the transfer function using block diagram reduction methods. This is Mani's Gate Tech Vision. This is the channel for engineering lectures. Thank you very much for watching the video. You can mail to me also. Thank you very much.